Okay, hi. So today I would like to introduce to you all regarding the fiber optics. So what is the fiber optics? I, Associate Professor Dr. Azra Awang from the Faculty of Science and Technology UTHM Campus Pagoh will introduce to you all regarding the fiber optics. So usually in my class, I start with the motivation quote. So today I love to share from the Mike Kafka. uh, he said that to be successful, you must accept all challenges that come your way. You can't just accept the one you like. So I hope my student, all of my student, can accept all the challenges come to you because sometimes all the challenges is the step to become a successful man. Therefore, I pray to you all, uh, in one day you will become a successful man. Okay. For first step, we go to the activity one in this Padlet, and you share to me about the what you know about the fiber optics. Okay, just share to me what you know about the fiber optics. Okay, okay. So I give you 30 seconds to fill in this Padlet about what is the fiber optic. Okay, so what actually is the fiber optic? Okay, I found that from your feedback, some of you said that fiber optic is a cable underground. Fiber optic is a unified. Fiber optic is the uh, transport uh, telecommunication system. Okay, so what actually the fiber optic? Okay, so from the Mokomi, uh, they share what is the fiber optic. So please feel free to hear this video.
What are fiber optics? The term is used to refer to the technology where the energy of light is harnessed to transmit data, much like you would use an electric impulse in a copper wire. Since light travels at the speed of 300,000 kilometers per second, fiber optic technology has greatly reduced the time in which information can be sent and received via fiber optic cables. Optical fibers. An optical fiber is a semi-flexible, transparent, and extremely thin strand of pure glass that has the diameter of a human hair. Thousands of these strands are arranged in bundles to make a thicker cable. A fiber optic cable is made up of five parts. Strands of glass that are bundled together to make one single channel for light to travel, called the core. The diameter of the core dictates how much information can travel at once. A protective sheath or coating of silica called cladding, which increases the total internal reflection of the core and hence prevents data loss. A layer of plastic surrounds the core and cladding to reinforce the fiber core. The strengthening fibers around the coating give added support to the coating. All this is covered in the cable jacket like any other cable or wire. Fiber optic cables exhibit a special property called total internal reflection. This is where the cladding acts like a mirror that continually reflects the light ray along its path, even across twists and turns. How does it work? A transmitter is responsible for converting an electric digital signal into a light signal by changing its intensity and pulse rate. If the ray has to travel a long distance, it will have to pass through an optical regenerator, which reboosts the strength of the ray by copying the message and sending a duplicate onward to its destination. Finally, the ray of light with the message imprinted on it arrives at the optical receiver. Here it is decoded back into a binary digital format. Uses communication. Massive amounts of data is sent and received over networks of fiber optic cables for cable television, phones, and the internet. Medicine. Since these cables are able to bend, doctors use them during surgery to shine light inside parts of the body which are hard to reach. Engineering. Fiber optic scopes are also used by engineers and mechanics to throw light onto parts of machines with a lot of twists and bends where light cannot easily travel. Project. How does a binary signal differ from an analog signal? Doctors use fiber optic scopes when they perform a particular type of surgery. Can you find out what this technique of surgery is and how a fiber optic scope is beneficial? Find out whether total internal reflection is possible with materials other than glass.
Okay, uh, to the project we will do in the end of this topic. Okay, so this is how the fiber optic will be transferred. You need have a transmitter and a receiver. Transmitter is for us is the mouse that transfer the data signal inside the fiber optic, which is the recorded transmission medium, into the receiver. Okay, so when we talk about something or said hello, so the data will transfer to digital and sent by the light by using total internal reflection, and there is the here will be hear what you said. Okay, so if we said hello and you hear hello. Okay, so optical fiber actually is a transparent material along which we can transmit light. Okay, so we have a fiber optic is a glass that can transmit the light or can transmit the pass rate to the uh, from the data to the receiver. Okay, so this is the history of the fiber optic. So fiber optic begins about 30 years ago in R&D in a Corning lab. Okay, so first installed is in Chicago in 1976. By the early of 1918, fiber optic fiber networks connected the major city on East Coast. So in 1918, by the middle of the 18, fiber was replacing all the telco copper. Why? Why fiber will be replaced to the telco copper? Because telco copper give many disadvantage um, disadvantage opposite to the fiber optic. Fiber optic can control. They have a few advantage from the fiber optic that can replace the copper. Okay, in the 19th century, CATV started using fiber to enhance the reliability of their network. CATV company also discovered they could offer phone and internet service on the same fiber and greatly enlarge their market. From the telco copper, we need to use the one wire or to one wire to the different equipment, okay, or different service. Okay, for example, here if you use the fiber, we only use one fiber that can cover phone and internet service. In computer and LANs, we started using fiber about the same time as the telco. Industrial links were among the first as the noise immunity of the fiber and industrial capability made its idea for the factor floor. So this is the This part is the one of the advantage of the fiber optic, which is they have can emit the noise of the fiber and the distant capability ideal to the factory floor. Mainframe storage network cam nets. The predecessor of today fiber is SUN. We call it storage area network. Okay, other application that already taught by the Mokomi. First, we have a medical, we have a telecommunication, we have for the oil and gas and company. So we also have for aircraft, ship, and automobile data buses, CCTV for security, link for consumer, digital stereo. And so today, fiber optics either in dominant medium or a logical choice for every communication system. So which a fiber optic they can use for the communication system. For example, the outside plan, fiber optic are used in telephone network or CATV. For premises, fiber optic are used in building and campuses. Just like wire, which can mean lots of different things, power, security, have HVAC, CCTV, LANs or telephone. So fiber is not all the same. So how to installing the fiber optic? So fiber is harder to install than 100 megabyte per second rather than copper Ethernet cable. But fiber is much faster. So the infrastructure were never to be upgraded so soon. In gigabyte internet is harder to install. So long copper cable is duplicated. It only have 20-pound pulling tension limit and kick with a run the high speed performance. So fiber has more strength and greater tolerance to abuse than copper wire. Okay. So in early optical communication, the French used a semaphore to transmit messages in 1790. So later system also send optical signal through the air, but cloud, rain, and other atomic disturbance can disrupt optical signal sent through the air. So this electric signal through wire avoid that problem. So this is how the started that we found the how to fabricate, how to generate the fiber optic. It's come from the one bottle of water that we put inside the bottle water we put inside the bottle and we we hold the bottle for the bottom and we launch the LED or laser beam inside that bottle when the water is passed through. Okay, the light is straight of water straight inside the water and bend with it because actually the light cannot bend. The light cannot bend. If you see the torchlight, you see the LED, you see the laser pointer, they will go straight. They cannot bend. Okay, therefore, but inside the water, you can found it. They have a bending. The bending is follow the water flow. Okay, so when this is started from 1940, which is first demonstrated that water is passed, the light is passed inside the water. So therefore, this the fiber optic will the fiber optic is appeared. Okay, so why it's happened? Because it occur the theory of the total internal reflection inside the in the water. So the total internal reflection will be discussed in the next topic. Okay, so we have also because of the light's bending, so the ray A come from the straight up and does not bend much. So ray B here is come at a shallow angle and bend a lot more. So from here you can see we have a reflected light and we have a transmitted light. So when we move the propagation of light from A to B, so you can find out from A to B. So from A, there will be a transmitted light. Okay, you can see the transmitted light, and we can see the reflected light. And when we move to the B, and at the same time, you can found it. It will occur total internal reflection. Okay, so uh, this is the theory how the fiber optic is come. Okay, this is the view from underwater, which underwater the light always shine down steeply even when the sun is low in the sky. So this is how the we understand regarding the reflection and the transmitter of light. Therefore, in actually in our life, in our worlds, we can find it as long we have a light, so we can see how light will be useful to us. So during 1920 to 1980, bare fiber or thin flexible roll of glass or plastic were used to guide light. So this fiber require air outside its fiber. Okay, so we also use glad glass clad fiber in 1960 for the medical instrument to light inside the body. So the glass was unable to transmit light far enough for the communication because in impurity of the loss, meaning that we have a large loss because of the bare fiber have air inside the glass. Okay, so this is the unique of the what do you need to understand about the fiber optic? This is decibel. Basically, the unit that used for the fiber optic is decibel, which is decibel are the algorithm scale of power. Uh, we can use the term of dB. A loss of the 10 dB means only 10% of the light get through. A loss of 20 dB means 1% of the light get through. So sunglass stop 99 of light, so they can cause of the 20 dB. For communication, loss must be not more than 10 or 20 decibel per kilometer. In 1966, fiber will be developed by the Charles Cow. So they can transmit the fiber that developed from the Charles Cow transmit 1 gigahertz or 1 billion bit per second. But the attenuation was 1000 dB per kilometer, so it could not transmit light for enough for practical communication. So Corning replaced to the Charles. Corning scientists developed low attenuation silica glass in 1917. So we can find out the video at Corning at the speed of light. We can see this video at the end of this topic. So optical fiber in 1977 used the telephone signal, come from the telephone signal, use infrared light with a wavelength of 850 nanometer to send data at 6.2 megabyte per second and 45 megabyte per second. But the loss was 2 dB per kilometer. So therefore we need the repeater to decrease the loss of the inside the fiber. So the refractor require every few kilometer to convert the light to make the signal is maintained. So 88 in 1988, AT&T laid the first fiber optic transtatic telephonic cable around 3,148 miles long from the connected from North America to the France. So they will add repeater every 40 miles with use the transmitter 565 megabyte bandwidth and use 1,300 nanometer light, which attenuation 0.5 dB per kilometer. So this is the part of the optical fiber. That will show in Manomi that we have a core, we have a cladding, we have a coating, we have string member and the outer jacket. So inside the core, the light will be propagated inside here. So the cladding will be prevent the light that will prevent the loss inside the core. So the coating will hold the cladding and the core, and the string member also hold this three part. Okay. So fiber with cladding basically developed in 1954 by the Van Hill Hopkins and Company. So cladding is a glass or plastic cover around the core. So they will protect the total reflection surface contamination and they reduce crosstalk from fiber in bundles. So basic structure of the fiber optic, we have also a jacket to determine the mechanical robustness of the cable, usually plastic or PVC. Buffer or coating will be protect of the fiber optic from physical damage. And this is the one of the we call it fiber identification. Cladding is the dielectric material with index of refraction less than the core material because it want to protect the core. So they made from the glass or plastic and the core is light propagate medium. It is a dielectric material, usually glass, and this is conduct no electricity. This is type of the fiber cable which is indoor plenum, outdoor cable, and interlocking Armos cable. So this is different because of the inside the fiber, uh, and we need to use where. Is indoor plenum we basically use inside the building. Outdoor is for the high temperature uh, place which can be used to out of the building. So in the fiber optic, we have a two type of the fiber, which is single mode and multi-mode fiber. So single mode basically have a core diameter around 8 to 9 micron, and the multi-mode has a core diameter of 50 to or 62.5 micron. But both of that covered by the cladding uh, with a diameter 125 micron. So this is the how we need to fabricate the fiber optic. Firstly, this is the famous not tool but instrument that can be fabricate the fiber optic. So this is use the outside vapor phase oxidation. From here, actually the we to fabricate. Firstly, we need to fabricate the capillary, and then from the huge capillary, we need to perform stacking, and then drawing perform into cane, and we got the thinning of the core inside the cladding. Okay, so we need to pull up the fiber to get the thinning of the core. This is how we can see um, the light will be the fiber optic will fabricate how to make the fiber optic.
Every time you talk on the phone or go on the internet, say your type travels to its destination through fiber optics. Voice and data gets transmitted via pulses of light through hair-thin glass fibers. Those fibers start out as large glass tubes. First, workers unwrap the tubes. Then they submerge them in a corrosive bath of hydrofluoric acid that removes any oil residues. Then they set a tube into each end of a lathe. As the tubes spin, they're heated with a hydrogen-oxygen flame. When the glass turns white, it's getting close to hitting peak temperature. At about 3,500 degrees, the two tubes fuse together. They put this new longer tube onto another lathe. As the tube spins, they inject a mixture of chemical gases inside, while a traversing burner heats everything up. The gas mixture contains liquid forms of silicon, an abundant chemical element found in nature, and germanium, a chemical element similar to tin that's used as a semiconductor in transistors and other electronic devices. As the gases heat, they undergo a chemical reaction that leaves a white soot on the inside of the glass tube. The heat fuses the soot. forming what will eventually become the core of the optical fiber. The glass tube itself will form the fiber's covering. When there's enough fused soot, they turn up the heat until the soot itself turns into glass. Then they heat the glass tube enough to soften it and to soften the new glass inside. The intense heat eventually makes the tube collapse on itself to form a solid rod. The internal structure of the optical fiber has been achieved, but it's in the form of a big bulky rod called a preform. So the next step is to thin it out. First, they excise the preform from the uncollapsed section of the glass tube. Then they install it vertically into the drawing tower, which will draw out the final shape. The drawing tower's oven heats one end of the preform to 3,600 degrees. The glass softens. Gravity helps pull it down, like honey dripping from a spoon. Then, using a glob of glass as a weight, they stretch the soft glass and keep stretching it until they formed a thin glass fiber. A series of pulleys measure the tension on the fiber as it's being drawn. A special monitor makes sure the fiber is precisely the right diameter, just 5/1000ths of an inch. Then the fiber passes through UV lamps that bake on an acrylic coating to protect against dust and other contaminants. Finally, the fiber is rolled onto a drum. From here, it's either shipped out as is or put into a cable. Fiber optic cables are expensive to produce, but they're smaller and lighter than traditional copper cables. They carry more information and need fewer repeaters to keep the signal from deteriorating. And unlike copper cables, they're immune to electromagnetic interference. They're also hard to tap without being detected. And all this is made possible by a complicated process based on a very simple principle: light traveling through glass.
So this is how to make the fiber optics. Okay, so this is the advantages of the fiber optics that are different to the copper wire that I told you before. So this is one of the advantages is the immunity from electrical interference. So immunity for electrical interference is mean the optical fiber can run comfortably through area of high level electrical noise such as near masonry and discharge lighting. Therefore, they have do not effects to the electrical interference and no crosstalk. When copper cable are placed inside by side for a long distance, EM radiation from each cable can be picked up by the others, and so the signal can be detected on surrounding conductor. This effect is called crosstalk. In a telephone circuit, its result in being able to hear another conversation in the background. So we can hear the sound that it's like the crosstalk. If you can imagine that the crosstalk is the one we hear. We You can see my finger. If you can see my finger, and when we put afar from our eyes, so we can see the clear finger. After we come to the close of our eyes, we can see the shadow. That's mean a crosstalk. Same with the in the copper cable. So they have the interaction or noise in the that's not clear to the signal. Okay, another one is the glass fiber are insulator. So being insulator, fiber optic are safe, for use in high voltage area. So they will not cause any arcing, can be connected between devices which are different electrical potential. So hand to earth loop current. So therefore, uh, they also the advantage in improved bandwidth because using like very high bandwidth and a low loss, which is capable to the low to the 0.2 dB per kilometer, and the size is small and the weight is less. So this is how the component that we need to increase inside the system, which is the repeater, or we call that sometimes they also have a fiber amplifier. So special fiber with erbium, it is used to amplify light without changing into the electrical signal first. Okay, so use stimulated emission, the same principle that make laser work. So this part of component that we need to know. Just in introduction to the fiber optic, we just info you all regarding what the system is about, meaning that how the history of the fiber optic, how the fiber optic is how to fabricate the fiber optic, what component used inside to become one system for the fiber optic. So first component before is the amplifier. Is the second one is wavelength division multiplexing. So this wavelength division multiplexing, if we can see wavelength division, meaning that they have a several signal or several wavelength that can transmit inside the same fiber. Uh, Meaning they can combine every wavelength to become in one signal. So this make the more bandwidth and more data to the system. Okay, for example here, we have a free will analogy. This is the TED in 1918 by using 565 megabyte per second, and they have electro-optical repeater. So this is when the fiber until toll pay and they have a traffic jam. Okay, but when using the amplifier, meaning that we doesn't have um, any distracted inside along the fiber. So but when we using the in 1980 we use the WDM. So WDM is like we can add on many wavelength. Okay, we add on many wavelength, multiple wavelength to make that traffic is more clear. So beside that, we have also component dense wavelength division, which mean can be used for 100 wavelength with a bandwidth up to the 1 terabyte per second. So what the safety of the fiber optic? So the fiber optic is you need to take care because it's a glass and also it's a small. Okay, so the light in the fiber can burn your retina if you use the light, if you direct, if you can see direct from the fiber optic, the retina of your fiber can be burned because they use sometimes the light is use the laser diode or use the, if you can see the torchlight, if you see the light from the torchlight long time, so it also hurt your eyes. Same that therefore you need to take care of your eyes and take care to uh, to light pass through inside the fiber to other way, not to your body or not to your eyes especially. So never look into a fiber unless you know no light in present. So use a power-meter to check it. So basically the infrared light is invisible. So therefore be careful. Okay, so take care. And fiber shroud. So this is when you to do the connection between the fiber, they have many shroud. So when you clip fiber, there are small shroud that we cannot see sometimes. So we need to be careful, and because the scrap is very dangerous, and the cliff end are also extremely sharp and can easily penetrate your skin. So they even worse in your eyes and mouth. So need a safety rules. So we need to wear glasses or safety glasses and dispose for all scrap properly. Put scrap on the black tape so we can see the scrap because it's look like glasses. So use a properly marked trash can. So we cannot use just throw inside the dustbin that for the all of the trash. So we need to special of the trash can. So all of the glasses or the scrap can be put inside that dustbin. Okay. Work on black pad which make the silver or glass easier to spot. So do not drop scrap on the floor, do not eat or drink whether in the work area. So in chemical safety, fiber optic splicing and termination use various chemical additive to clean the fiber, and please follow the instruction for use carefully. Basically, the chemical that is isopropyl alcohol because it's used has a cleaner but it's a flammable. So zero tolerance for dirt. So airborne particles are about the size of the core of single. So they absorb a lot of light and they may scratch connector if not removed. So dirt of the connector is the biggest cause of scratches on the poly connector and high loss measurement. So that's why we need to hygiene for the work area and keep dust cap on the all connector so the connector will be clean and no dust inside the connector and will not burn your fiber. So use lint-free pad and isopropyl alcohol to clean connector to clean the dust. So this is basically the what's the fiber optic, the introduction of the whole of the fiber optics. Okay.
With nearly 2 billion kilometers deployed around the world, optical fiber is the backbone of today's most advanced telecommunications networks. Fiber is assembled into optical cables that link continents, cities, and neighborhoods around the world. This thin, flexible strand of ultra-pure glass is capable of carrying voice, data, and video information in the form of light signals at very high speeds. Let's take a closer look at this revolutionary transmission medium. Optical fiber is very thin. One strand is about the diameter of a human hair. It is comprised of two basic elements made of glass, the core and the cladding. The core, the center part of the fiber, is the area through which the light signals are transmitted. The cladding layer completely surrounds the core, keeping the light from escaping. There are two different types of fiber, single mode and multi-mode. Single mode fiber has a small core diameter designed to carry light in a single path over long distances. It has high information carrying capacity and low attenuation, and is the most widely deployed optical fiber in the world. Multi-mode fiber has a larger core, which allows light to travel down many paths simultaneously. Typically, multi-mode fiber is deployed in data centers, local area networks, and storage area networks, where it is more cost-effective than single-mode fiber. Corning invented the first low-loss fiber in 1970 and has continued to deliver significant performance improvements for the past 40 years through continuous innovation. Three key attributes that can limit the speed or information carrying capacity of the optical fiber are attenuation, dispersion, and bend-induced loss in the form of macrobending and microbending performance. Attenuation refers to signal loss along the length of the fiber. In this illustration, the light gets dimmer as it travels down the fiber. It can be caused by the quality of the glass itself or can be induced by bending. Dispersion is the distortion of a signal along the fiber length. This occurs because different spectral components of the optical signal in the optical fiber travel at different speeds. In this example, different wavelengths are represented by the red and yellow light. Macrobending and microbending are optical effects that occur when the fiber is bent from a straight axis. Microbending is an attenuation increase caused by high-frequency, small-radius bends along the length of the fiber. Macrobending is the attenuation associated with bending or wrapping the fiber. Both of these conditions can allow light to leak out of the fiber, meaning some of the original signal is lost. Using a bend-insensitive fiber like Corning ClearCurve single-mode or multi-mode fiber will greatly reduce the loss caused by macrobending. Optical fibers operate on the principle of total internal reflection. which keeps the light within the core and guides it down the length of the fiber. Refraction refers to the bending of light as it passes from one substance to another. The glass used in the fiber's core has a higher refractive index than the glass used in the cladding, so that the light can be trapped in the core by reflection at the cladding interface, as it propagates down the length of the fiber. Two additional characteristics of single-mode fiber that are important are cutoff wavelength and mode field diameter. Cutoff wavelength is the wavelength above which a fiber will support only a single mode. Wavelengths below the cutoff support two or more modes. The cutoff wavelength is determined by the fiber's refractive index profile, the length and bend of the fiber, as well as the cabling process and deployment conditions encountered during use. In a single-mode fiber, some of the optical power is actually guided outside the core. In fact, as much as 30% of the light propagates in the cladding layer of some fibers. The mode field diameter defines the size of the optical power distribution in the fiber. Multi-mode fiber has two important characteristics: numerical aperture and core size. Numerical aperture is the measure of the angular range of acceptance of light into a fiber. The angle over which a fiber accepts light depends on the refractive indices of the core and cladding glass. Core diameter is a fundamental design parameter of multi-mode optical fiber. The larger the core, the more modes of light can propagate through the fiber. Multi-mode fiber has a much larger core size than single-mode fiber. Optical fiber is strong, flexible, and reliable. Inch for inch, it's stronger than steel and more durable than copper. Fiber offers excellent signal performance over a wide range of environmental conditions. Since fiber carries light instead of electricity, it is unsusceptible to lightning strikes or electrical faults, and, unlike copper, it does not corrode or rust. As a result, fiber reduces maintenance costs and has a proven record of reliability in the field. In fact, it is common for customers to report to Corning that cables installed in the late 1970s or early 1980s are still in use today. Optical fiber is cost-effective, durable, and scalable, has low attenuation, and it features the superior transmission quality needed for high-speed transmission of voice, data, and video in today's leading applications. To learn more, visit our website or contact your Corning account representative.
Okay, so that's the overview of the introduction of the fiber optic. So I need you to go to activity 2 to give you some reflection regarding the what is the fiber optic that you know. Is it the same with the first impression of your impression about the fiber optic, or is it the different? Okay, so go to the activity 2 and don't forget to write your name and just feel free um, to write what is the fiber optics. What is the fiber optics? Okay, so I think this is the end of this topic, and we will see you in the next topic. Thank you.